Welcome to episode 4 of our series. So now on the previous episode, we saw how to use the second method on adding columns and how to manipulate in order to change the still sections and the still properties. And we also saw some kind of a problem with the method. We end up having to delete the join box in order for us to rotate the columns, the gable columns inside, the gable columns for that section. So yeah. So now on this episode, we're going to do connections. That's an interesting part. So first of all, we need to check some information regarding our connections, which is something that I need to do, or I encourage people to do when you're doing drawings. When you get a drawing from an engineer's drawing, your structural still notes are very important to adhere to. So for example, if you have noticed, when I change material when editing steel properties, I used S355JR for material because that is what the engineer has specified that the material should be. This material will appear on your bill of material, will appear on your drawings as well. So it's important to make sure that you check these notes. So now we want to check notes regarding to plate thicknesses and bolting. So if you check under from item 8, 9, 10, and 11. So item 8 says all gusset plates to be a minimum of 8mm thick plate. Item number 9, all end plates to be a minimum of 12mm thick plate. Item number 10, all stiffener plates to be a minimum of 10 thick plate. Number 11, all base plates to be a minimum of 20mm thick plate. So those are the notes regarding plate work. And notes regarding bolting, let's check. I say item number 3, all bolts to be grade 88 to adhere to SANS fabricator to supply all bolts and nuts. Doesn't show us what's the minimum bolting size. The other spec that tells us about bolting is number 17. It says all bolts to be electro-galvanized. So that means that we might get information on our bolting on the connection drawing, which is the second drawing. All right, so from here, we need, first of all, we're going to do our base plate. So these are the views or the cut, the enlarged sections or the connections that we need for our base plate. So here, as you can see, it says it's the base plate is 400 by 610, and our bolts, we've got 8 by 8 diameter 26 holes, 4 M24 HD bolts. That means our holding down bolts. All right, and then we've got 2 diameter 16 holes on our base plate. So that's something to check on. We've got stiffeners on our base plate, and we have got a 20mm base plate and 30mm grout. Right, so those are some of the things that we need to add. Now, as you can see on this plate, on this column, we've got a gusset plate that's connecting the bracing to our column and the base plate. Now, our base plate connection does not come with a gusset. There is a connection specified especially for connecting a bracing to a column and a base plate. So we're going to see that later on when we have added our bracing, then we can do the connections. For now, we just want to focus on the base plate. So, all right, let's get into it. So just make sure that your connection volt is activated. So we go to connection volt, click the plus sign, then so the first icon on your connection vault, it's called your favorites. So any of your favorites or any connection that you mark as your favorite comes and gets pinned on the first icon. So if you want it to be easy for you, and you know that there's some connections that you use now and again, it's just good to pin them. Makes your job easy. So for example, how do you pin a connection? Right, let's do this. Base plate, right? If you come to your base plate, just put your case on top of your base plate connection. You see that star there, it says add to favorite. Just click that, and then when you go to the favorites, there's your base plate. If you want to add another one, let's say apex haunch connection, click that, and then go to your favorites. There is your apex connection. So that's how you add to your favorites. So now let's go to our base plate. Now, one thing that you also need to understand, what makes advanced a bit easier, is because you've got the selection order, how to apply the connection, and a bit of a description at the bottom there. So for example, the selection order is you select the column in this case. That's simple as that. Then let's go to another different column, another different connection, so I can give a bit of an explanation as well. So you see, selection order, we've got 1 beam, comma 2 beam. So what this means that is you first select the first beam, you hit enter, select the second beam, and then hit enter. That's how you do the connection. You don't select these 2 beams at once. For example, by just coming here and saying apex, and then you select that and say enter. As you can see, nothing happens because it first wants you to select the first beam, you hit enter, and then select the second beam, hit enter. So let's activate that command again. So apex haunch, select enter, select enter. So there is your connection. So that's one thing to keep in mind, to say how you enter your connection. You can't just select all of the 2 and you expect the connection to just pop up and give you everything that you want. You have to follow the order. So we don't want that. So we go back to our base plate, since you're starting our base plate. So you can just use any column. So we've selected that, and then it says, do you want an additional concrete object? So we don't want, then we just default is no, then we just hit enter. Right, then there is our base plate. Our base plate has been created. Now let's edit our base plate to suit the drawing that's on the left. Sorry, to suit our drawing or PDF on the right. So first of all, properties, there is drop down arrow, there is nothing there. Library, if you've created some base plates before and you've saved them, then you can go to your library. Joint design, if you want to design your own, do your forces and everything, you go there. So what our area of concern is here, where it says base plate. So let's go there, and our plate thickness is 20. That's our plate thickness, right? So set out points, you can change whether you want projection from the center, total. It's just up to you. So for example, if you say projection, right, this is going to affect your base plate dimensions. As you can see now, this is how your projection is done. So if you say, just for curiosity's sake, let's say 150, you see it then reduces. So that, as you can see here, we've got projection 1. So it also shows here. So projection 1 is from the edge of the flange to the edge of the plate. That is your 150. So that's how you, if you don't want to make them all equal, you can uncheck that. Then you can now individually manipulate them to the values that you want. So There's that as well. So if you go back and say total, right now, the projections have been grayed out. Now you're using the total length of the plate. For example, our plate on one side, which is say plate length, which is item 5, right? Item 5. So our plate length here is 610. So we come there and say 610, and then plate width, which is item 6 there. As you can see, it shows you where item 6 is and what item 6 does to your base plate. So our width is 400, so we go there and we change to 400. So there is our base plate. But now remember, we are not editing our bolts, we're editing the base plate. So our bolts will remain where they are until we edit them. Our bolts will remain where they are until we edit them. All right, so we go back to the base plate layout. So one thing that you have to understand with advanced steel, you might change one thing under a section or a header, but then to fully customize it, you might need to go to the second tab or to the second button to order to fully customize it. So as we have seen there, we had to change from projection and you went to the second tab for bolt plate for base plate dimensions to be able to customize it. So that's one thing to keep in mind. All right, so let's go back. So now it says column shortening. All right, remember our column is going straight to point to level 00, and we've got 30 millimeter grout plus a 20 millimeter base plate. So we have to shorten this column. The column will be shortened based on these two values. So for example, if we, let me just put it like this. Let me see if I can get a perfect view. All right, something like this. All right, so let's see what happens when I say column shortening none. As you can see now, the column hasn't been shortened, and if we check from above, right, that our grid line is exactly, our grids are on exactly 0, 0, 0. That's on level 0. So now our base plate has gone under the level 0, the level 00. So you see, that's the effect of column shortening. Now we want to shorten our column by the grout plus the base plate thickness. So now adding the two, we've got 50. So we go to column shortening. Instead of going by base plate, if you say by base plate, it's going to shorten the column by 20 millimeters. But now we can't do that. We need to shorten it by 50 millimeters. So we go and we say value. And then it says shortening value, extension value, which is what we need. We're going to add 50. So now if I just zoom and do that, you see our UCS is exactly on 0, 0, 0, which is our 0 level, and we've got that distance there to the base plate. That distance there is 30 for the grout. So that's how you do your column shortening. And then the direction, now you can change the direction of the shortening to say horizontal or vertical. It's up to you. But now, as you can see, vertical doesn't apply in this case. That's why the joint box is now indicated in red. So it has to be by column. So that's how you do your shortening. All right, then let's go to the next option that we need to change. All right, so for you to just pan around, you just click and hold the center button of your mouse. That's when you can have this option just to pan around. If you want to orbit, you hold shift and the center button of your mouse. That's how you do orbit in advanced still. I forgot to mention that as well. You might be wondering, how am I doing it? So that's how you do it. So let's go to this. We have edited. Let's go to base plate corners. If you want to notch your corners, this is how you do it. We are not doing that. It's not part of our design. Anchors and holes, right? So when we go to our view there on the drawing, it says 8 diameter 26 holes for M24 HD bolts. So our diameter of the bolt, so this is the diameter of the bolt. This anchor diameter is the diameter of the holding down bolt, not the diameter of the hole. So we go and choose our M24, and then anchor type there, you can switch it. You can choose a different type of anchor, whether you want. There are different types of anchors that you can choose. So, but from us or from me or from this drawing, it's a holding down bolt. So we switch to holding down bolt. And the grade, remember, according to our structural steel notes, the grade is 8.8. So click the drop down arrow. There is our grade 8.8. Right. Assemble anchor. This is how your assemble is going to be assembled. And then the anchor, length of the anchor. In this case, we're not given how long is the anchor. But if your anchor is 600 long, you can just change there and say 600. If it's 500 long, you can just change there to 550. There is 500. So it depends on how long your anchor is. So there you go. So if you are not given the length of the anchor, right, you can just come here where it says create hole only. So if you do that, if you zoom in, you'll see that you've only created the holes. The anchor is not there. So in our case, our anchors were not given. We're just going to create the holes as per se. So now, right, let's go back to hole diameter. Now the hole diameter now, this is where it comes in. The hole diameter is 26. This is you can change this to 26, you can change it to 28, or you can change it to 50. So you can manually change it when if you check this create one only, that's when you can manipulate the diameter individually. But let's say we uncheck this, right? So here it says hole tolerance definition. Here it's on automatic. So if you want to put a value, let's say you want to, by default, the tolerance is 2. So that means our hole is 26. So maybe you want your hole to be 30 or 50, right? So that's where you add your tolerance, right? Or 20 or 50, whatever that you want. So this is where you add your tolerance. So in this case, we're not worried about that. What we need is just to create the hole only. So the hole only, the diameter is 26. That's what we want. Then we go to washer plate. We don't need that. Then anchors parallel web. This is where it gets interesting. Anchors parallel web. All right. So, all right, the intermediate distance to our anchors, which are these, this hole there, and this one on the other side, this one as well. So our intermediate distance is 400. As you can see, you might see that the center is running along the edge of the plate, and that edge, that's where we've got our 400. So we've got 2 of these, which are these on the drawings, those holes, and our intermediate distance there is 300, not 400. Right, that's more like it. And there is no offset from the center, so we don't need any offset from the center. We've got one group of bolts, so there's no group 2. So if there are other groups, you can say to the left, then you add the group number 2, you add the group. So unfortunately, it's not, it shows that the bolts are on the outer side. They are not part of the plate. So hence This is group number 2, but we don't need group number 2, so we go and put it back as none. All right. Then we go to anchors parallel to the flange. All right. Now, anchors parallel to the flange, this is what we're talking about. All right. So in this case, we need, it should be 4. Right. But now these 4 the other 2 are outside of our base plate because of the intermediate distance. Now our intermediate distance from the drawing is these ones. These are our intermediate distances, which is 170, 170, 170, and then 50 from the edges. So we go and we say intermediate distance, it's 170. Right. There we are. Our holes are now inside the base plate or on the base plate. Right. Then from there, we go to welding symbols. Welding at the web, it's 6. Welding at the flange, it's 6. Fillet welding, which is exactly what we want. So if the welding has changed maybe to 8mm or 10mm, this is where you edit and the type of welding as well that you want. All right, so this one, gonna leave it as it is. It's perfect. Then we go to stiffeners. All right, so under stiffeners, we don't need a leveling plate. Usually your grout is made from your concrete plinth. We don't need a leveling plate. We don't need a shin plate. We don't need that. Shear anchor, we don't need that. Shear anchor dimensions, we don't need that. Web stiffeners, we need these. Web stiffeners, we need these. So our web stiffeners are these ones. We've got that, and then we've got, this is the other stiffener as well that we need. So in this case, the dimensions of the stiffener, we have been given the total height is 50, and then that notch there is 20. So and that one at the top is 20, then the overall diameter for that dimension for that is 110. Let's see if we can make that happen. All right, so we go to create stiffener, right, and then say both sides. All right, then from there we go to where is the, okay, this is the detail, 104 and 150. All right, so let's say that all stiffeners should be 8mm thick minimum. Let's just confirm what they said. All right, all stiffener plates to be 10mm thick, rather 10mm thick. Okay, so stiffener thickness, this should be 10. All right, then that's good, that's correct. And then stiffener width, right, which is your number 2, which is there, which is your 104. Right, so it's 104. All right, so it's going exactly to the edge. And then stiffener height is 150, which is this dimension there. So stiffener height it's 150. And then corner finish, straight, concave, you can choose whether it's straight, and if it's concave, you can put the concave. That's where it comes in there. Usually it's a straight for you to allow the weld to run, because if you remove that corner finish, that means that your stiffener is going to be kind of wedged, because it's going to be sitting on top of your welding that will be been done for the column and the base plate. So it has to be straight, and you can specify the value, whether it's 10, 20. It's up to the design as well. Then now we come to the outside chamfer height. Right, so outside chamfer height is item 5. That's the outside chamfer height. So remember, our total height for stiffener is 150, and we would want to have that corner there as 20, so it should be around 130. And then outside chamfer width, we have 104, so we can put it 184 rather, minus the 20, so 84. Right, this is exactly what we want. So let's go to the second one, which is flange stiffener. All right, let's create both sides. Thickness is 10. Stiffener width, which is this one, stiffener width is 110. Where is the option? Stiffener width, which is 110. All right, then the stiffen height, it's 150. Then corner finish, straight, size inside 20. Outside chamfer height, right? Outside chamfer height, we are saying it's 130. And then outside chamfer width, right? That's 110 minus 20 goes to 90. All right, that's what we want. Then we are finished. This is how you create your base plate. Right, then if you want flange stiffeners, you can, outside stiffener, you can also play around with these. It's not a problem. Stiffener old preparation, you can also play around with these. So this is how you play around with. So you can explore more. And then if you go to holes, right, they are those two holes that we mentioned that we needed. If we go to the plan section of the base plate, right, that if you want to create those galvanizing holes, just click there, and then as you can see, they have been created. So you can make the dimensions to say it says diameter 16, so diameter 6, so it becomes 16 there. Arrangement, we've got 2 holes centered or 2 holes diagonal, and then so you can play around with these options, right? So we've got grouting holes as well. You can create these 16 and then offset in the Y. You can change it, so you can play around with all these. But the main issue is creating a base plate, and that's what we have done successfully here. So from here, in order to copy your base plate to all these other columns, because the columns are the same, so the base plate is the same for all those columns. The option that you have, the first option is to say you select the joint box, right click and say propagate joint. As you can see now, the joint has been placed where similar steel sections are available. So this one, these two did not get the connection. Let's see what is the material there. 46178 by 54. 46178 by 54. It's somehow they did not get that connection joint. But what propagate means is it takes, you are basically telling the software to say, take this connection and go and place it where there is a similar steel section or a similar connection, or where you want the connection to be. For example, as long as the steel properties are the same. So as long as the steel properties are the same, go and place this connection there. That's what propagate does. So that's the first option. Then the second option, let me just delete. So if you want to delete anything that came with a joint box or a connection box, you just select an element inside, or an element that came with the connection box, and just delete that. So you can select the base plate, you can select the stiffener, it still works. So that's how you delete anything that came with the joint box. You don't delete the joint box. If you delete the joint box, you are now you have now deleted the rules that join these things. So if you want to delete now the base plate, you have to do it manually. You're now selecting each and every element and deleting manually. So that's not what we want to do in this case. Let's skip that, let's undo that. So we're back there. Now, the other option of adding a connection, which is it's a bit lengthy. You go to your advanced L2 palette, and then you go to tools, which is the second option. We've got these two icons here, right? And then these other ones as well, right? So this one says, if you put your mouse, says copy joint, joint copy, and then this one says joint copy multiple, right? What this one does is, if you say copy, you left click on it, and then you select your joint box and say enter, hit enter, and then you go to the column or the position where you want it. You select the still section and say enter. That's how you add your column. You add your base plate. That's another way of copying your base plate to all these other elements as well. So you just select all those, and then there you go. So that's another one. So the other method is this one that says create a joint box this one that says joint copy multiple. Right, so you're doing multiple connections. So you can also play with that as well. Just find out what it does. But for now, we want to just make sure that all our columns have got the base plate. So let's finish up with this one here. Right, then we are done with the base plate. We are done with the base plate. We are done with the base plate. That's how you edit it. So even if you don't see the connection box, right? Even if you don't see the connection box, what you simply need to do is select the element that came with the base plate with the connection box, and right click, and then go to advanced joint properties. Then your tab is going to come up. Then you can now edit. That's how you can, bring about the connection joint if you want to edit it. So right there, we are done. That's how we add our base plates.